All right, so 12.2.3 is continuing on trigonometric functions. So yesterday we started talking about solving right triangles. Okay? So one of the tools you can use that you hopefully learned and practiced really well in geometry is obviously Pythagorean theorem. The other one you learned in geometry is how to use trig. So you use regular trig. Hey guys, is there a question? No? Okay. So you're either going to use regular trig or inverse trig, depending on what you're looking for. You're going to use regular trig when you're solving a side, and you're going to use inverse trig when you're trying to solve for an angle. Okay, so today we're going to add the third one, which is special right triangles. All of these are for right triangles, but this third one is special right triangles. So special right triangles means basically that the angles are going to have special measures. Does anybody remember either one or both of the special right triangles?
30, 60, 90.
Okay, one of them is a 30, 60, 90. There's one more. Anybody know the other one?
45, 45, 90.
Right, the 45, 45, 90. Okay, so we're going to draw each of these. So 30, 60, 90 looks a little something like this. Already put a little box for the 90. The smaller angle, obviously the 30. The larger one, the 60. And the three sides, if it's a perfect or a special 30, 60, 90 triangle, the three sides are always going to be in the same ratio, which means you can set up a proportion and then solve if it's not exactly, well, if it's not the numbers, you'll set up a proportion. Okay, so opposite the 30 degree is the side that's in the ratio of 1. Opposite the 90 degree angle is the side that's in the ratio of 2. And opposite the 60 is the rad 3. Okay. That's the 30, 60, 90. The other one on the 45, 45, 90, if they're 45 and 45, the two sides opposite them are going to have the same ratio, right? Because 45 and 45 are the same measure. So their two opposite sides are going to be in a ratio of 1 to 1. And then opposite the 90 is going to be the rad 2. So on your assignment, you're going to see questions sort of like example number 1 here, where it's going to say something like the cosine of theta is equal to 1/2. And they're going to want you to solve and say which angle that is, okay? So theta, that little symbol right there, just means that it's an angle. And you'll see that in here. You'll see the Greek letters representing the angle measurements, okay? And since we're solving for an angle, should we use regular trig or inverse trig? Inverse trig. So we're actually going to change this to the inverse cosine of that ratio of 1 to 2. And so if you look at these two special right triangles, the 30, 60, 90 and the 45, 45, 90, you might be able to, just by looking at them, figure out which angle they're talking about. Okay? Cosine is the ratio of what to what?
Adjacent over hypotenuse.
Adjacent over hypotenuse. Okay? So which of these two triangles has a 1 and a 2 in it? Right? The 30, 60, 90. Okay? Everybody see the 1 and the 2? Okay? So we want the adjacent and the hypotenuse. So is that going to be the 30 or the 60? it's going to be the 60. So you're going to say that the theta, whoop, I didn't draw that very well, the angle theta is going to be equal to 60 degrees. Yes, sir. Oh, that just means therefore. Sorry. You don't have to write those. Sorry. Example number 2. We're going to look at the tangent of alpha, and it's going to be just equal to 1. All right, so another Greek letter here, alpha. We saw it the other day. Since we're looking for that angle alpha, we're going to use the inverse of tangent. And we're looking at 1. So is there a way to rewrite 1 in a ratio, kind of like example number 1 where we had 1/2? 1/1. So tangent is what is what?
Opposite over adjacent.
Opposite over adjacent. So of these two triangles, is it the 30, 60, 90 or the 45, 45, 90? It's got to be the 45, 45, 90. Does it matter if it's opposite and adjacent? Does it matter if it's this one or this one? Kind of either. Okay, so we'll say that alpha is going to be equal to 45 degrees. And if you want to put the therefore, you can. All right. Another thing this section brings up is something called cofunctions. Cofunctions are just going to be angle pairs that are complementary. So in geometry, you learn about supplementary and complementary, and you talk about supplementary a lot, right, in geometry, where it adds up to what? 180. And you kind of mention complementary, but it doesn't come up a lot. Okay, so it basically means the sum is going to be what? 90. So the pairs are going to be the sine of theta is going to be equal to the cofunction of the cosine of 90 minus theta. And I'll show you one in just a second. It takes longer to write all these down than it will be to even answer these questions. Okay, and then tangent theta is cotangent 90 minus theta. Secant theta is going to be equal to cosecant 90 minus theta. And then they're going to be the opposites of each other too. So if you have this one, you're going to have it backwards as well. So cosine of theta is going to be equal to the sine of 90 minus theta. And this one backwards too. Cotangent theta, tangent 90 minus theta. And the last one, oh, that should be a C. Cosecant theta is going to be secant of 90 minus theta. All right. So once you have them all written out just once, you're going to see how easy these are. So some of the questions are like this. Example number 3. The tangent, and then you're going to have some Greek letter. I think this one's called phi. And then it's going to say something like is equal to the cotangent of 30 degrees. So tangent is going to be the cotangent of 90 minus that amount. So all you have to do is take 90 minus 30. Started to write the answer. 90 minus 30 is going to get you 60. So that Greek letter is going to be equal to 60 degrees. That's all you have to do. But it's not going to be nice, pretty numbers like 30. It's going to be like 17 or 43. So you just have to take your calculator. 90 minus whatever that number is. Okay? Any questions on any of those?